NSF guys, one of the things I wanted to touch on is you rattled off a list of contaminant metals that might be contained in that. You want, part of your testing is to make sure those are in such insignificant levels or not detected. And that's one of the things you test for. When I read the Sequest spec sheet, it says contaminant metal analysis, and it lists antimony, beryllium, chromium, lead, selenium, arsenic, cadmium, copper, mercury, and thallium. Right. Next to each one it says non-detect. So that would, I just want to verify, that would indicate that they are not present, correct?
Well, that would mean that it's not detected at the level of that instrumentation, whichever they ran the analysis. Basically, I'm assuming that I'm looking at the spec sheet you're probably looking at right now. It says ND, non-detect for all those different metals.
Right.
That's just basically indicating that based on the detection method used, they were not able to find any of those metals at a detectable quantity.
And is the method reliable?
I'm not sure what method they use to get there on their own spec sheet.
I can use Hawk equipment for that.
Do you use what?
The Hawk, H-A-C-H, the company that manufactures a lot of the equipment for detection.
For lab equipment?
Yeah, correct.
Okay.
We use standard lab equipment. I don't know, I don't have the numbers in front of me as far as what the non-detect level was, but I think it was in parts per billion. So I don't know. I don't have it here in front of me.
Yeah, I know, and it's highly technical. I understand. So anyway, well, that's what's listed on your spec sheet, which is available for public reviewing.
And NSF's testing frequency, basically, we need to test the product initially prior to certification, and then again on an annual basis. That's for each of those trace metals that Kevin mentioned, plus the radionuclides and the fluoride test.
Yeah, and by the way, I standard temperatures for when NSF comes into our company to do an inspection, they never call for an appointment. They just show up.
Okay. All right, gentlemen, I'd like to actually take some questions from the public, and I appreciate you guys taking the time to be with us. So if you could please stay with us just a little longer, we want to take some questions from members of the public. Is that okay?
Absolutely okay with me. I just wanted to make a comment here.
Yeah.
If that's okay with you. We did the math here. I think the math is pretty telling. Now, if anybody has a calculator in the audience, you may want to just check this out. Now, you're using Sequest at a half part per million in your system. Is that correct?
Correct.
All right. So let me just do it. I did it figured out at 1 part per million. Now, 1 part per million gallons is 8.34 pounds. Okay? Now, if you divide that into 365 days, comes out to 0.022 pounds a year. Now, if a person is living, that comes out to you drinking about 34.246 gallons a day. In order to get 8.34 pounds into your system in 1 year, you have to be drinking 34.246 gallons a day, okay? Now, that is nobody drinks that much water a day. And if you live 80 years, and in your lifetime you wanted to do that division, you go down to 0.000275 pounds. But again, you have to do the math in terms of how much water you're drinking a day. I think 8 glasses, and then you have other stuff that has phosphates in it. But we're talking about the amount of product we're putting into 1 million gallons is quite a small amount. And as the NSF person had mentioned, that this is all food grade and it's a nutrient for the system. And, from our water, from what you're treating, it wouldn't even be significant to give you what you require per day in terms of phosphate ingestion.
Okay.
Thank you.
All right, who's got a question? Karen Coyote has a question. Go ahead.
Yes, I have a question for all three of you. We're like a conversation. Kevin, Blake, and Michael, I have been researching the processes of OPP and how it actually works. And it is my, but first, Kevin, in your testing, I understand that you test for contaminants within the chemical that's put into the water supply. Is there any specific health testing that your organization does, any cited studies that document the health effects of long-term exposure to humans?
Can you repeat that question? I couldn't hear very well.
Is there any studies that your organization does that addresses the long-term health effects of these substances on human beings?
The question is studies about the long-term health effects on human beings. Do you guys do those studies? How do you know about the long-term health effects on
this one particular orthophosphate sequence, not in phosphates in general. This one particular one.
As far as this particular combination of phosphates,
yes, sir.
We do not perform any type of in-house test as far as chronic testing of this particular product. What we would do is we would look at the available scientific literature out there, which would have evaluated the various components. But again, when you're looking at phosphates, the way the body processes these phosphates, even if you have a proprietary blend of various phosphates, such as what we're dealing with here, the body is going to still break those into the individual phosphate components. And so essentially, even if you have this unique mixture of phosphates that's present, the end result will still be the body absorbing just the straight amount of phosphate as orthophosphate, which again is an essential nutrient. So
you would rely on the scientific data available for each of the
phosphates in general.
For each of those food-grade phosphates, which is all they
okay, now my next question is for the Sequest sales representative. I also have some material from your company, and I also want to give you some kudos for making a very effective product that you claim Sequest consistently performs independent of water quality, independent of pH, independent of the presence of calcium or magnesium, independent of time, temperature, and independent of anything. And this is claims that you made because of your proprietary processes that basically encapsulate the metal particles and in the very small particles and grinds them down to coat the pipes. This is the proprietary part of your equation. Is that correct?
I'm not familiar with exactly what you're referring to on the website that you got, but it sounds, generally what you're saying is, we either sequester or we disperse. If you want to get very technical, we can, but that's a simple way of saying it.
Well, in your literature, it says.
So what's the question?
Okay, the question is: Sequest forms a uniform, continuous metal phosphate coating with the base metal of distributing piping that does not involve the presence of calcium. That's a good part. You don't have to add calcium. Okay?
Yeah.
But AlphaSmart created this proprietary SQ547 new and improved blend, right, that allows Sequest to form an integral, uniform, non-building metal phosphate. This metal phosphate is very small because it is more effective. The smaller particles are more effective in removing the metal than the larger ones, and that's why yours is special, unique, and isn't dependent on pH in the system. Is that correct?
You know what? I apologize. I think you're reading it a little too fast for me to get you. But I think what did you just say? That we're not dependent upon pH.
Yeah.
She's going to come up to the speaker.
Okay. Thanks. I appreciate that.
Alrighty. I have some material here from your newsletter.
Yeah.
Okay. And which says Sequest forms a uniform continuous metal phosphate coating.
Well, okay. Let me say what that means. We're bonding. What our Sequest does is everybody coats. Okay. All other phosphates are coating on the metal. You got like this white, fluffy, grayish, fluffy phosphate coating, an orthophosphate coating that coats the metal pipes. And what it's doing is, it's just a coating. What we do is we're actually bonding with the pipe metal to prevent any further corrosion on the pipes. Okay, so we're actually bonding rather than putting this fluffy coating on top of it.
Right. I
Okay.
understand that. And this is independent of pH and chlorine, which makes your product so darn effective, right?
That's correct.
Okay. We had a citizen call your sales representative not that long ago, and they had a conversation with your company, and they did kind of describe this encapsulating process. And just for the group here in the room, I want to describe that. Okay? And you're free to comment after I'm done. OPP works by an encapsulated process. You put OPP through an ionization process, giving it a positive charge. As it travels through the pipes, it attracts the positively charged metals from 1 to 20 microns in size, and as the process continues, it grinds these metal particles to a smaller size. And that's part of what I just quoted you from your newsletter a minute ago. Okay? And when asked about the actual size of the particle, the salesperson hedged, and they wouldn't actually say exactly how big that particle would be, but he did say this. When asked exactly what filtration system would remove these particles from our water, he said that an RO system would get plugged up very quickly. Now, an RO system has a filter at very small size, and I have it written down here, but I don't know exactly where it is.
Right.
But to actually plug up this RO filter, the particles would have to be very small. And what concerns me is that these particles are encapsulating metals. Okay, that's their function. Now, I don't think the pipes can actually capture all those particles, and so you're having some of these particles coming through the water system.
Okay. So wait. Let me just parenthetically. Let me just tell you that what you're talking about is